Although from some viewing angles they are superimposed and appear as a single tail, in extreme cases a comet's tails can be nearly 1 astronomical units in length. So very long-tailed things. Comets can be divided into two classes based on their orbital parameters. Short period comets are those with a period of less than 200 years and hence a semi-major axis of less than 34 astronomical units. Short period comets have other characteristics in common. Most short period comets have moderate inclination. I is less than 30 degrees, though a few are retrograde. I is greater than 90 degrees. Most short period comets have fairly large eccentricity with an E of around 0.8 is a typical value. At present, there are roughly 200 short period comets known. The most famous short period comet is Comet Halley's Comet, with a P of 76 years, so pretty short compared to the periods. It is also one of the few retrograde short period comets with an I of 162 degrees. After a few hundred perihelion passes, a comet tends to lose all its ices. So after, going around the sun and coming close to it, enough times, it's sort of lost its ices because of sublimation. Thus, after less than 10 to the 5 years, so less than a million years, a short period comet becomes an inert pile of rubble. An inert pile of rubble. Given this brief time scale, there must exist a repository of cometary nuclei in the cold outer solar system from which the supply of short period comets is replenished. One obvious repository is the Kuiper belt. This would explain why most of them have relatively small inclinations, which match the relatively small inclination of the majority of Kuiper belt objects. But how can we explain the short period comets that are on retrograde orbits? To explain the origin of retrograde short period comets, it helps to consider the origin of long period comets. Long period comets are defined as comets with a period of more than 200 years, and hence semi-major axis of more than 34 astronomical units. Some long period comets have periods that are very long indeed, with a period of around 3 times 10 to the 7 years, implying a semi-major axis of 100,000 astronomical units. Long period comets have other characteristics in common besides their long orbital periods. These are as follows. Long period comets have random inclinations to the ecliptic, with as many being on retrograde orbits as on prograde orbits. Long period comets have extremely high orbital eccentricities of around 1. Over 800 long period comets have been detected over the course of history. The Dutch astronomer Jan Oort, with OORT being the name here, proposed that long period comets reside in a large, roughly spherical cloud of radius around 50,000 astronomical units, centered on the sun. This distribution of cometary bodies is called the Oort cloud. The radius of the Oort cloud is not negligibly tiny compared to the distance of around 270,000 astronomical units to the sun's nearest neighboring star. The orbits of cometary bodies in the Oort cloud can be perturbed by passing stars. This alters their orbits and sometimes permits them to approach the inner solar system. Those few objects with perihelion distances of less than 4 astronomical units grow commas and tails and can be observed by us as comets. Retrograde short period comets such as Comet Halley represent long period comets that have had a close encounter with the Jovian planet that has flung them onto a smaller orbit. So close encounter with the Jovian planet might fling them onto a smaller orbit. The chemical composition of cometary nuclei indicates that they were probably formed about 20 to 30 astronomical units from the sun between the orbits of Uranus and Neptune, where the temperature of the pre-solar nebula was around 100 Kelvin.